Assalamualaikum and hi everybody. So today we will cover the topic 1, Introduction to Computers and the Computer System. The lesson outcome. So the first one that you, at the end of the class, the first thing that you have to be able to is to explain the overview and the history of computers. Okay, we have 0th generation until the latest generation. And then second one, you must be able to explain the basic components of the von Neumann machine, the input, output, processor, memory, and the storage. And lastly, you must be able to explain the modern computer system and hardware in brief. The system unit, input, output, storage, network, and communication. So the first subtopic is overview and history of computers. The 0th generation. So the period is from 1642 until 1940. It was called a mechanical era. The first inventor that we want to see is Blaise Pascal from 1623 until 1662. Okay, he was the son of a tax collector and he was a mathematical genius. He designed the first, he designed the first mechanical calculator called Pascaline based on gears. So this calculator can perform addition and also subtraction. And then we have Gottfried von Leibniz from 1646 until 1716. He was a German mathematician, built the first calculator that can do multiplication and division. Okay, his calculator is called step reckoner, but it was not reliable due to the accuracy of contemporary parts. And then we have Charles Babbage from 1792 until 1872. He invented an analytical engine. Okay, it had 4 components: the store or memory, the mill or the computation unit, the input section use the punch card reader, and the output section use the punch and printed outputs. And then we have John V. Atanasoff and Clifford Berry. Okay, these two guys developed the ABC or Atanasoff-Berry computer. So this computer, ABC, is the first totally electronic digital computer. So this is the Blaise Pascal, the calculator that he invented. Okay, this is Gottfried, also invented a calculator. And then this is Charles Babbage, invented an analytical engine. And then we have Dr. John V. Atanasoff and Clifford Berry, invented the ABC, Atanasoff-Berry computer. And then, okay, next we move to the first generation. The period is from 1940 until 1955, okay, 15 years. So the technology used in the first generation is vacuum tube. So they use the vacuum tube for circuitry and magnetic drums for memory. The characteristic of vacuum tube, okay, the size is bulky, very large. It was made from glass, so therefore it is fragile and it is short-lived because of the heat. Okay, and then it used a great deal of electricity, so therefore your bill will be very expensive. The computers relied on the machine language and could only solve one problem at a time. Only one problem at a time, imagine. And then the input use the punch card and the paper tape. The output will be displayed on a printout. The invention, we have the ENIAC, called Electronic Numerical Integrator and Computer. The inventor was John W. Moseley and J. Vesper Eckert. It was called, the ENIAC was called a first all-electronic digital computer. And then we have ADVAC, the IAS, and also the UNIVAC one that is known as the first commercially available computer. So what are the main features of the first generation computers? Okay, first, it uses the vacuum tube technology. It was unreliable. It only support machine language, very costly, generated lot of heat, slow input and output devices, huge in size, need of AC, non-portable because it was so big, consume lot of electricity. Okay, the types of computers during this generation, we have ENIAC, we have ADVAC, we have IAS, UNIVAC, IBM 701, IBM 650. Next, so this is the sample or the picture of the ENIAC, the ADVAC, the UNIVAC, and also the IAS machine. Okay, as you can see, they were so big. Okay, and then we have second generation from 1955 until 1965, 10 years. So the technology used is transistor. So what is a transistor? It was made of specially treated silicon which control the flow of electric current. It generated less heat, okay, and it wouldn't burn out. It allowed computers to become smaller than the first one, the vacuum tube computers, faster, cheaper, and more energy efficient. Therefore, it was more reliable than the vacuum tube. And it uses assembly language that allow programmer to specify instruction in words. So you learn assembly language in CSC159. So what are the main features of the second generation computers? It uses transistors. It is reliable in comparison to the first. Okay, compared to the first generation computers, smaller size also compared to the first generation computers, generated less heat compared to the first generation computers, consume less electricity faster than first generation computers, but it is still very costly and AC is still needed. And the supported machine, it support machine and assembly languages. The types of computers during these generations are IBM 1620, IBM 1794, CDC 6600, CDC 3600, UNIVAC 1108. Okay, so these are the pictures. Okay, even though it is smaller than size, but it is not small enough for us to use. It is still big, smaller than the first generation computer. And then we move to the third generation computer. The period 1965 until 1980, so 15 years. The technology used is integrated circuit. We call this IC, integrated circuit base. The computers of third generation uses the integrated circuit in place of transistor. So it replaces the transistor. So a single IC has many transistors. resistors and also capacitors along with the associated circuitry. So who invented the IC? Jack Kilby. Jack Kilby invented the integrated circuit. This development made computers smaller in size, see, smaller in size, reliable, efficient, similar to the second generation that compared to the previous generation. So in this generation, remote processing, time sharing, multi-programming operating system were used. And then the language used is a high-level language. Okay, example, Fortran, COBOL, Pascal, BASIC, and ALGOL. So what are the main features of the third generation computers? More reliable compared to the previous two generations, smaller size, less heat, faster, lesser maintenance, but still costly. AC is still needed, consume less electricity, and it supported high-level language. Types of computer during this generation are IBM 360 series, Honeywell 6000 series, PDP personal data processor, IBM 370 or 168, and TDC 316. Okay, so I have mentioned Jack Kilby. Okay, Jack Kilby invented the IC, integrated circuit technology. Why is it said that it is co-invented by Jack Kilby and Robert Noyce? Okay, did they work together? Okay, let's see Jack Kilby first. Jack Kilby demonstrated it half a year before Noyce on 17th September 12th. So half a year before. So they did not work together, okay? He was from Texas Instrument. He got Nobel Prize in Physics in 2000. Okay, the IC invented by him is germanium base that demonstrated continuous sine wave. And then we have Robert Noyce. Okay, Robert Noyce, misspelled here. He is the co-founder of Fairchild Semiconductor and the Intel. Okay, the IC invented invented by him is silicon based. Okay, during this one I already tell you, he founded the Intel with the Gordon Moore. So Noyce came up with the same idea that is completely independently from the Jack Kilby. Okay, the silicon used by the Noyce operates at higher temperature. So therefore, they say that they co-invented the IC, but actually they do not work together at the same time. Okay. And then the fourth generation from 1980 until present, the technology used is VLSI. What is VLSI, class? Okay, you can search in the internet. VLSI is very large scale integration microprocessor base. Okay, very large scale integration microprocessor base. So the invention of the VLSI microprocessor, it has thousands of IC, okay, of IC built onto a single chip, and it could be mass produced. So you can build your PC. And then the computers become even smaller, more powerful. We have the GUI, graphical user interface. We have mouse. We have handheld devices. And the architecture used, we have open architecture. The hardware design was made available to anyone. Anyone could write the software or build the hardware. So the main features of the fourth generation, it used the VLSI technology. It was very cheap, portable and reliable. The use of PC, personal computer, very small in size. It used pipeline processing. No AC is needed. The concept of internet was introduced. Great development in the fields of network, and your computers become easily available. Okay, these are types of computer. DEC10, Star 1000, PDP 11, Cray 1, which is a supercomputer. Cray XMP is also a supercomputer. Okay, and then we have the last generation, fifth generation, from the present until beyond. Okay, the technology used is ULSI. Okay, before this, VLSI. So what is ULSI? It means ultra large scale integration technology. Okay, the invention, we have AI, artificial intelligence. The goal of AI to develop devices that respond to natural language input, capable of learning and self-organized. It is used in the robotics, use the nanotechnology, anything smaller than the micro technology. The age of connectivity, it released the WWW standards in 1991, possible to connect computers all over the world, and we shift toward technology that focuses on mobility. Okay, this is called the wireless revolution. So what are the main features? The ULSI technology, the development of true AI, the development of natural language processing, the advancement in parallel processing, advancement in superconductor technology, more user-friendly interfaces with multimedia features, availability of very powerful and compact computer, but at a cheaper rate. So types of computers are desktop, laptop, notebook, ultrabook, Chromebook. Okay. Next, the second subtopic of this topic is the basic components of the von Neumann machine. So the concept is called stored program concept. Okay. It was introduced by the John von Neumann. Who is he? A genius who spoke many languages, was an expert in the physical sciences and mathematics, had a total recall of everything he ever heard, saw, or read. Okay, he was a consultant on the ENIAC project. He proposed significant improvement over the ENIAC design, therefore the invention of the ADVAC and IAS. The principle of the Von Neumann architecture, there are 4 principles. The first one, data and instruction are both stored in main memory while being processed. Second one, it is sequential processing of instruction. The third one, it has binary data processing. And the last one, it consists of CPU, memory, and input-output systems. This is a more complete view of the computer system architecture that integration, either from the human or otherwise, consists of, okay, the CPU. The first one is CPU here, and then the main memory here, the input-output devices here, the mass storage here, and also the interconnection network, the bus. Okay, you will see what is a bus later. Sorry, not this one, this one. So a CPU is a central processing unit. It contains the control unit, CU, the ALU, arithmetic logic unit, and the interface unit. So ALU performs arithmetic and Boolean logical calculation. CU control the processing of instruction. It also control the movement of data within the CPU. Interface, it moves instruction and data between CPU to the other hardware components. So it uses the bus. So what is a bus? It is a bundle of wires that carry signals and power between different components. Imagine the components hardware, the input, the output, okay? Imagine you are from Segamat to your hometown, okay? So you need something to carry you from that places, okay? So let's say you use bus. So bus in reality is a vehicle to carry something you lah. Takkanlah bus tu pergi carry yantu kan? Okay? So bus carry you from Segamat to your hometown. But in computer, so the bus is not a vehicle, but it is a bundle of wires, acts as a vehicle to carry signals and power between different components. The components that you saw in the previous slide. And then we have, okay, so what is a memory? This is the definitions, okay? Definitions. What is a memory? It is a short term, okay, not long term, short term storage for CPU calculation. It holds both instruction and data of a computer program. What is input devices? Okay, these are the example of input devices: keyboard, mouse, scanner, punch card. Example of output devices: monitor, printer, fax machine. Okay, the storage: hard drive, optical media, diskettes, magnetic tape. And then this is the definition of bus. You already said this before. Bundle of wires that carry signals and power between different components. So in the Von Neumann architecture, a small set of circuits can be driven to perform very different tasks depending on the software which is executed. Software is a program, so supposedly it will be slashed. So the primary function of a CPU is to execute, primary function is to execute the instruction that is fetched. You take from the main memory. An instruction will tell the CPU to perform one of its basic operation. The CU is the one which interprets the instruction to be executed, okay? the CPU already fetch the something instruction from the main memory. So the CU will take that instruction and interpret the instruction that it wants to execute and will tell the different other components. After it interpret, it will tell the other components of what to do. And then the CPU include set of registers which are temporary storage. This is the definition of register. Temporary storage devices that is used to hold intensively used data and the intermediate results. Next is the modern computer system and hardware in brief. So what is a computer? Let's say this question will ask in your quiz, in your test, okay? What is a computer? A computer is an electronic device operating under the control of instruction stored in its own memory that can accept data, process the data according to specified rule, produce result, and then store the results for future use. So in brief, it is a device that receives, store, and process information. So here is the input. Process is the process. And here is the output. Of course, when you process something, you want to have the output. The components of a computer in general, it is the combination of hardware and software. So it becomes a computer. So what is a hardware? It is a device that processes data to create information. Okay. You have input, you have output, you have storage devices and processing devices. What is a software? A software is also called a program. Okay, it is a step-by-step instruction that tells the computer how to do its work. Its purpose is to convert the data to become a useful information. So the computer hardware may contain many electronic and mechanical components. Okay, that is a computer hardware. So you have input devices that allow you to enter data and instruction. You have the keyboard, you have mouse where you click, and then you have output device. It is a hardware component that display the information to one or more people. Okay, you have monitor, you have speakers, you have printers, you have fax machine. And then we have system unit. Case that contain the electronic components of the computer that are used to process the data. Okay, case. And then we have storage device where it will record or write or it will retrieve or read the items. So it will record the item to the storage media or it will read or retrieve the item from the storage media. Okay. And then we have communication device that enable computer to send and receive data, instruction, and information to and from one or more computers or mobile device. You have your Wi-Fi, okay, router. So this is the example. The input, the output, the case, okay, this one casing, the case that contain the CPU, RAM, and other supporting components. Okay, here you have a CD-ROM, CD drive, CD-ROM. Okay, so that you can burn your CD so that it become an output. It become your secondary memory. And you also have your hard disk. It is also a secondary memory where you store all your data. So what is a computer hardware? Software. What is a computer software? Okay, software is also called a program. It tells the computer what tasks to perform and how to perform. Okay, it can be classified into two. The first one is system software. Example of system software is operating system and utility program. It provides an environment for user to execute the application. If you don't have this operating system, so you cannot use your Office. Okay, so it provides environment for you to execute your other application. And then it enables the application software to interact with the computer hardware. Kalau tak, you punya software, Word semua ni tak kenal macam mana nak pergi connect dengan lain-lain komponen dalam you punya CPU tu. Example is the operating system. I already said this before. And then the second categories of the computer software is an application software. It can be general purpose software, it can be specialized software, it can be an apps. So it is used by you, the end user. It is a program that performs common tasks to the user. Okay, Word, Excel, PowerPoint, Photoshop, Visual Basic, Alice. Okay, that are the example of application software. And then we have network and the internet. The internet. A network is a collection of computers and devices connected together, okay, often wirelessly via communication devices and transmission media. Okay, normally wirelessly. See, wirelessly. And then the internet is a okay, let's see. Wirelessly, if this is a cable or the cable lah, RJ45 ni, it is not wireless. Okay, maybe you have a router at home, so it is called wireless, where you can connect from your laptop to your printer, from your laptop to your PC or to your handphone. Okay, the internet is a worldwide collection of networks that connect millions of businesses, government agencies, educational institution, and the individual. In general, it connects everything. Okay, so here we see here everything in this world can be connected using the internet. Next, we have types of computer. We have supercomputers, we have mainframe computers, we have mid-range computers, and we also have personal computers. So what is a supercomputer? A supercomputer is the fastest, most powerful computer. So these fastest supercomputers are capable of processing more than 1 quadrillion, okay, instruction in a single second. In a second, it can process more than 1 quadrillion instruction. Fast enough? So you have the Oth Jaguar supercomputer, which is the fastest supercomputer as of May 31st, 2020. This supercomputer named Jaguar, okay, it enables the scientific simulation for exploring solutions to climate change and the development of new energy technologies. So let's see supercomputer. What are the common application for supercomputers class? Okay, common application. It can be used in testing mathematical model, complex physical phenomena or design. Okay, climate and weather, evolution of the cosmos, nuclear weapons and reactors. Other thing can to develop a new chemical compound, especially for the pharmaceutical purposes and also for security cryptology. Alright, so this is the example of your supercomputer. Okay, they are big. And then we have mainframe computer, still big. So what is a mainframe computer? It is a, where's my, okay. It is a large, expensive, powerful computer that can handle hundreds or thousands of connected users simultaneously. It occupies special wired, air-conditioned rooms and capable of great processing speeds and data storage. Okay. So it was like a big centralized machine. You see the picture that contains the large memory, huge storage space, multiple high-grade processors. So it has ultra processing power compared to the standard computer system. So where will it be used? The mainframe computer. So the importance for large-scale organization, for scientific research center, for consumer statistic census data. Okay, because it is capable to execute multiple complex programs concurrently at the ultra speed. Okay, example of sectors that use these mainframe computers: healthcare sector, defense sector, education sector. Maybe the educational, the university is very big sector. International university need to track lots of person, employees, teachers, students, and others. Okay, and then we have retail industries, the e-business, banking, stock exchange, ticket reservation in railway and airlines, credit card verification, insurance sector, telecommunication, and also finance sector. Okay, because it handle large, it can handle hundreds or thousands of connected users simultaneously. Okay, and then we have mid-range computers or servers. They are the computers with processing capabilities less powerful than the mainframe, yet more powerful than the PC, personal computer. It can control access to the hardware, software, and other resources on the network. It can provide centralized storage area for program data and information. Okay, so this is the example of your mid-range computers or the server. And then we have PC, personal computer. It can perform all of its input, processing, output, and storage activities by itself. There are 5 types of personal computer. We have desktop, we have laptop, we have tablet, we have smartphone, and we have wearables such as your smartwatch. Okay, that is all for CSC116. Okay, there is a tutorial that need to be answered. Please hand in before our next class. Alright, if you have any question, then therefore you are welcome to contact me, you are welcome to contact me um, using the Telegram or the Google Classroom. Okay, class? See you next class. Thank you. Bye. Assalamualaikum.